Hello everyone, welcome back to MKTG 675. In this session, we'll learn Python basics, the core building blocks we'll use all semester for marketing analytics. I'll walk you through each concept with small repeatable examples in Google Colab. Keep your Colab notebook open so you can code along. Python is a high-level interpreted language. That means we can write code in simple, readable lines and run them immediately. Perfect for exploring data and iterating fast. It's one of the most widely used languages for data analysis and machine learning, so mastering the basics will pay off quickly in this course. Let's start by running a simple line to confirm your notebook is working. We'll start with a quick warm-up. This line multiplies 24 hours by 60 minutes by 60 seconds and stores the result in a variable named seconds in a day. Executing the next line simply evaluates the variable, so the notebook prints 86400. In Colab, a bare variable on the last line displays its value. Variables persist across cells. Here, we reuse seconds in a day to compute seconds in a week. This is a recurring theme. Define once, reuse often. Print sends human-readable text to the output area. We'll use it often to check intermediate results. Let's study data structures in Python. First structure is list. A list is an ordered collection. Think of it like a flexible shopping list. You can add, remove, and slice elements. Let's create a product list, then update it. Products is a Python list, an ordered, mutable collection. Square brackets create a list. Printing it shows all elements. Lists are zero indexed. Product square bracket 0 is the first item, then square bracket 1, then square bracket 2. Append adds a single item to the end of the list. Remove deletes the first matching value. If the item is missing, it raises a value error. This is a slice. Start at index 1 and go up to, but not including index 3. A bare name at the end of a cell echoes the value. A slice of 1 to returns a one-element sublist. Insert position 1, value desktop places the item at that specific index and shifts the rest to the right. Extend concatenates another list. Here, a 2-item list with keyboard and mouse. You can also use plus to create a new list from 2 lists. Because lists are mutable, prefer extend for in-place growth, and plus when you intentionally want a new object. Second, dictionaries. A dictionary maps keys to values. Great for looking up attributes by a unique identifier, like a product name or customer ID. Here we create a Python dictionary. Use curly braces to open and close. Each entry has a key, like laptop, and a value, like 1500. Notice that the value for tablet is another dictionary inside, with keys discount and retail. This redefines the dictionary in a simpler form. Now tablet just maps to 300. When we reassign the variable, the old version is replaced. To access a value, type the dictionary name, then square bracket, then the key in quotation marks, then close square bracket. This prints the price of laptop. The method .keys shows all available keys in the dictionary. This line assigns a value to a new key, smartwatch. Because smartwatch did not exist before, Python adds it. If the key had existed, it would simply update the value. Delete dictionary bracket. Smartphone removes that key and its value. If you try to access smartphone afterwards, you'll get an error. A for loop with dictionary.items returns pairs of product and price. Here, for each product, we print the phrase the price of, followed by the key and its numeric value. Using an F string avoids type errors. This example shows a common mistake. You cannot use plus to directly join a string and an integer. Python will throw a type error. The fix is to wrap price in str or to use an F string as shown earlier. Third, tuples. They look like lists, but they are immutable. You can't change their contents after creation. Tuples are great for fixed pairs like coordinates, image sizes, or any data you don't want accidentally modified. Here we create a Python tuple. Tuples use parentheses. Unlike lists, they are immutable, which means you cannot change them once created. This tuple has two numbers, 1920 and 1080, representing width and height. To access items, we use square brackets with an index. Index 0 gives the first element, which is 1920. Index 1 gives the second element, which is 1080. We can also unpack tuple elements into variables. Here, width is assigned to the first value and height is assigned to the second. Printing shows width 1920, height 1080. If we try to assign a new value, Python raises a type error. The error message says, tuple object does not support item assignment. This demonstrates that tuples are immutable. When creating a tuple with only one item, you must include a trailing comma. Parentheses alone are not enough. Here, single item tuple equals 5 comma, and Python recognizes it as a tuple, not just the number 5. Fourth, sets. Use sets when you need uniqueness, no duplicates, and when you want fast membership checks, like deduplicating customer lists. Here, we create a Python set. Sets use curly braces, just like dictionaries, but they only store unique values. The set unique customers contains Alice, Bob, and Charlie. Notice that the order may not be preserved when printed because sets are unordered. We can add a new element using the add method. Here we add David. The set now contains Alice, Bob, Charlie, and David. If we try to add Alice again, nothing changes. Sets automatically prevent duplicates. Sets also support mathematical operations. Union merges two sets, keeping only unique items. In this case, all customers include Alice, Bob, Charlie, David, and Emma. Intersection keeps only the elements that exist in both sets. Here, that means Bob and David. Your turn. Pause here and complete 4 quick tasks. Create a list of marketing channels and modify it. Make a product prices dictionary and loop through it. Define a tuple for a banner size and try changing a value to observe immutability. Build a set of customers and practice union and intersection. Resume when ready. Here we create a list called marketing channels. It has 3 elements: email, social media, and SEO. We use append to add a new element, content marketing, at the end of the list. Remove deletes the item SEO from the list. Now only email, social media, and content marketing remain. This slice takes everything from index 0 up to, but not including, index 2. The result is email and social media. Here we create a dictionary where each product name is a key and each price is a value. Laptop maps to 1200, smartphone to 800, and tablet to 400. This updates the price of smartphone from 800 to 850. We add a new key called smartwatch with a value of 250. Finally, we loop through the dictionary. For each product, we print the phrase "the price of" followed by its value. Here we create a tuple for banner dimensions. It has width 1200 and height 600. We unpack the tuple into width and height variables. Then we print banner width equals 1200 pixels, height equals 600 pixels. If we try to change one of the dimensions, Python raises a type error. This demonstrates that tuples are immutable. Here we create a set of customers. Sets only keep unique names and the order is not guaranteed. Add inserts a new element, David. Adding Alice again has no effect because sets ignore duplicates. Union combines 2 sets, removing duplicates. Here we get Alice, Bob, Charlie, David, Emma, and Frank. Intersection keeps only the names that exist in both sets, in this case, Alice. Next, Boolean expressions, statements that evaluate to true or false. We use them to make decisions. Here we assign the variable A to 10 and B to 20. If we just type the variable name and run the cell, Colab will display the stored value. This prints whether A is equal to B. Double equals checks for equality. 10 equals 20 is false. This prints whether A is not equal to B. 10 is not equal to 20, so this is true. This prints whether A is less than B. 10 is less than 20, so the result is true. Here we create a variable called marketing channel and assign the string email. Running just the variable name displays its value. This compares the variable marketing channel with the string social media. Since the value is email, the result is false. This compares the variable marketing channel with the string email. Since they match exactly, the result is true. Conditionals execute different code depending on a condition. Use if for a single check, add else for a fallback, and chain elif for multiple bands. Let's model a quick business example. Here we assign sales to 1500. The if statement checks if sales is greater than 1000. Since 1500 is greater than 1000, the condition is true, and Python prints sales target achieved. Now sales is 800. The if statement checks if sales is greater than 1000. That is false, so Python runs the else block and prints sales target not achieved. In this example, we use if, elif, and else. Sales equals 800. First, Python checks if sales is greater than 1000. That is false. Then it checks elif sales greater than 500. That is true, so it prints moderate sales performance. The else is skipped. This nested structure shows how you can place one if inside another, but in this case, with sales equal to 800, the outer if is false, so nothing prints. Be careful with nested logic. Often a clear if-elif else chain is easier to read. To make it work, let's test some other options. For example, we can set the sales to 1200 or 400. Also, to prevent a potential nested if issue, we can revise the code. If sales is 1200, the result should be high sales performance. If the sales is 400, nothing is shown due to nested if. To prevent this nested if issue, simply we can use else if. If the sales is 800 and also we want to add one more category, we can revise the code like this. Functions package logic into reusable blocks. They take inputs, do some work, and return outputs. This keeps notebooks clean and avoids copy-paste errors. Here we define a function using the keyword def followed by the function name greet. It takes one parameter called name. The return statement sends back the text hello followed by the given name. When we call greet with the argument Alice, it returns hello Alice. We assign that to the variable message and print it. This function is called calculate total. It takes two parameters, price and quantity. It multiplies them and returns the result. When we pass 50 and 3, it returns 150. We print total cost equals $150. Loops repeat actions over data. Use for when iterating over a collection or a numeric range. Use while when you need to repeat until a condition changes. Here we define a list called products with 3 items: laptop, smartphone, and tablet. A for loop goes through each item in the list one by one. For each product, it prints the phrase product : followed by the item. The result shows product laptop, product smartphone, and product tablet. This for loop uses the range function. Range with the number 5 generates the sequence 0 through 4. For each value, the loop prints iteration : followed by the number. The output is iteration 0, iteration 1, iteration 2, iteration 3, and iteration 4. This loop uses range with 3 arguments: start, stop, and step. It begins at 1, ends before 101, and counts by 10. The output is iteration 1, 11, 21, 31, 41, 51, 61, 71, 81, and 91. Here we use a while loop. We start with count equal to 0. The loop repeats as long as count is less than 3. Inside the loop, we print count is followed by the number, and then increase count by 1. The output is count is 0, count is 1, and count is 2. After that, the condition is false and the loop stops. Time to practice logic and control flow. Pause here and complete a Boolean check for a number between 10 and 20, and if, elif, else greater. Define is even, loop to print 1 through 10, a while countdown from 5, and print customer names in uppercase. Resume when finished. Here we check if the variable x, which is 15, is greater than 10 and less than 20. Both conditions are true, so the result is true. Here we check if the variable channel is either email or social media. Since it equals email, the result is true. Here score is 85. The if condition checks if score is greater than 70. That is true, so it prints pass. Here we assign score to 85. The first condition score greater than or equal to 90 is false. The next condition score greater than or equal to 80 is true. So grade becomes B. The program prints grade B. This defines a function discount price that takes 2 arguments, price and discount percentage. It multiplies the price by 1 minus discount over 100. For 120%, it returns 80. This function is called isEven. It uses the modulus operator to check divisibility by 2. 4 divided by 2 leaves no remainder, so it returns true. 7 divided by 2 leaves a remainder, so it returns false. This for loop prints the numbers from 1 through 10. This while loop starts at 5 and runs as long as count is greater than 0. Each time it prints the value, then subtracts 1. The output is 5, 4, 3, 2, 1. This for loop goes through a list of customer names. The method upper converts each name to capital letters. The output is Alice, Bob, and Charlie. Great work today. You learned Python's core data structures, lists, dictionaries, tuples, and sets, plus booleans, conditionals, functions, and loops. These basics are the foundation for everything we'll do with real data sets in marketing analytics. Keep this notebook. Revisit the examples and practice blocks whenever you need a refresher. See you in the next session.